Hey guys, for day one of the circuits unit, we are going to first cover information about the role of the battery in the circuit, and then also the theory of how the circuit basically works. And then we will move into three different kinds of circuits subsequently over the next few days. So let's take a look at this. It's going to link our electrostatic stuff that we just did in class, and it's really important to jot down some notes because there's a daily practice quiz that you'll do each day this week, and you will need this information to help you answer some of the questions. Alright, so here we've got a battery, and most of us are familiar with these as the power source of the circuit, and you can still refer to the battery as that, but now that you are learning a little bit more about electricity, what we're going to say is that it's a little bit more than a power source. And one of the main roles of the battery is to do work on charges. So when you think of a circuit, I'm going to draw some wires coming off of this. We maybe will have a little light bulb connected, and we know that the role of what's happening in the circuit is that little charges are moving through the wires, and this is a very basic sort of explanation for right now. Little charges are moving through the wires and lighting the light bulb in this case, but it could be a motor, it could be other things. The whole role of the battery is that it's going to do the work on the charges so that they're able to move throughout the circuit and then do work for us or convert their energy. So we're going to look at this as an energy transformation. So the role of the battery so far is to do work on charges, and that's super important. Let's take a look at that. So the battery's job is going to be to separate out electrons from places where they want to be. So where we could say there were 3 protons over here, now this is an oversimplified example, but it gets the point across. In order to drag these electrons away from those protons, that is not natural, right? That won't naturally occur. So the battery is going to actually physically do this job. It's going to separate the charge. So that's something you could write down right away, is that battery separates charges. Now, what is it used to actually separate the charges? Because you can't get some output with no input. In other words, I can't drive my car if I don't put gas in it. So where is the energy coming from that is doing the work? Well, inside the battery, there are chemical cells. We're not going to talk about how those work. We just are identifying that the chemical cells provide chemical energy, and that chemical energy is going to be doing work, and the result is that eventually it's going to be converted into electrical potential energy. So that's the main process. There's the three forms of energy transfer. Chemical energy, it's doing work, which is the transfer of energy, and the result is that the electrons will have more electrical potential energy. So when the electrons are here, I'm going to draw these little ghost electrons that are not actually there anymore because we already moved them, but let's say they're there on the left hand side. This configuration that you see here is one in which there is no electrical potential energy, because those electrons or those particles have no potential to move. They're not naturally going to move from there. Now, if I use this chemical energy and I drag them away, so they get dragged to this side over here, the result is now that those electrons have gained electric potential energy by the work that the chemical energy from the battery did on them. It's kind of like if I had a whole bunch of marbles on the ground and I lifted them up into the air. So you can, if you're more visual, you can just think about that. Okay, here I have a whole bunch of marbles. They won't naturally move up into the air, but I analogous to the battery in this example, has to physically move them up to this higher position. Now that they're at a higher position, they have more gravitational potential energy, and that can be converted into other things if we were to drop them. But in this case, what we're talking about is instead of lifting masses, we're moving electrons from places that they don't, or that they would rather be, to places that they don't want to be. So the electrons would like to be over here on the left-hand side. I'll draw one there, that's where they start. But they're going to end up over here because of the work that the battery does. Now there's one more thing we need to add to the story so that we really understand what's actually happening in the wires. Alright, so the battery does work. Okay, so we'll do this in steps here. So we have chemical energy, and I'm writing this out very specifically because in the Rube Goldberg project you're going to need this information as well. So we have chemical energy. The battery uses that to do work on the charges, and the result is that the charges have an increase in electric potential energy. Alright, now that electric potential energy can then be converted into multiple different things. We could have heat, like thermal energy, light, which is also a kind of thermal energy actually. We could have maybe even kinetic energy in the form of a motor, which could be like on a fan or a little car. There's a whole bunch of different ways that can happen. Now, what happens when you separate charge? So when you actually separate charge, something else will happen that we looked at before. So let's say I have a metal plate here and a metal plate here. We're looking at it from above. And I'm going to connect a battery to the metal plates. Now what the battery is going to do is it's going to separate charges. On this plate right now, there's an even number of positive and negative charges because we say the plate was neutral when it first began. But what the battery is going to do is it's going to pull these electrons off of here, because remember it's doing work by using the chemical energy, and that's going to leave one side positive and the other side negative, because it will dump those electrons on the other side. Now the result is that you'll have one plate that's positive, I'll hide those away, and one plate over here that is negative. And when you have this separation of charge, what happens is an electric field forms. Remember we said field lines always point away from positive and towards negative. When you have an electric field, if I were to dump a little positively charged object in that field, it would be repelled by the positive side, attracted to the left, and it would move in the direction of the field lines. That is what's happening inside the wires of a circuit. Okay, so putting it all together, here's my battery. I take it with a wire and I'm going to connect it to a light bulb. And what I'm going to do here is, by connecting it this way, this side of the battery becomes the high potential, that's how we describe it, the high potential side, and the other side is, the negative side is the low potential side. And that is convention, that's what we call these sides, because inside the battery here is what's happening is all these little electrons, which we are pretending are positive because that's how they were first assumed to be, even though we know they're actually negative, but we still call it this way. That place is where the little charge carriers have a high potential energy. So we call that location the location of high potential. Once you connect the wires, they can jump right through the circuit naturally, and they'll go back down to here on the low potential side. Using the gravitational analogy again, this is what it would be similar to. Okay, I have a hill set up here, and there's a cliff on this side, and there's a whole bunch of marbles or balls over here, and I'm going to be the battery. The human being is the battery. He uses his chemical energy to do work, to raise these little particles up here to the top. This would be like the positive terminal of the battery. This is the negative terminal. And so the negative is also down here. Now that they're all up top here, if I were to just kind of give them a little nudge, they would naturally fall down towards the negative. So what's super important to remember is that in a battery, the electricity always flows from the high potential to the low potential. That is natural. Inside the battery, where we're pushing electrons up to the high potential side, which is not natural, that will take effort and work, and that work is coming from the battery. So this is the end of this video. Watch parts again if you were confused or need to review some things, and the next video will cover series circuits, which are also required for the day 1 practice quiz.